Hello everyone and welcome back to our course on supply chain management. And today we are going to be discussing our fifth lecture now, and we are going to be focusing on new product innovation. So the goal of this lecture is to find out the differences between a traditional and sequential approach of a processing in a company and a new product development approach, which we call a CTF approach, corresponding functional approach, and to find out which one is better to be implemented in maybe a future company or in a company now. Okay, so first of all, you can recall the value life cycle we talked about in lecture 1. So in value life cycle, we basically went through a combination of the product life cycle and a new product innovation cycle to basically build up the value life cycle. And I've mentioned before, the new product development is really important in terms of a development itself and in terms of a timing and planning, because sometimes now in the market today, new product is definitely competitive in the market. So although it can be really costly to develop a new product, it can be really risky, and you might have to raise the price very high to gain your profits and to break even. But however, new product innovation is definitely providing competitive advantages for a company in the market. So now we've integrated our new product innovation and our supply chain management, and now we are going to try to find out what way of processing we can use to produce our products from the concept stage to the date we launched our product in the market. So time-based competition in 1990s started in the 1990s while supply is larger than demand. So when supply is larger than demand, the market is definitely more competitive, because not all products can be sold, not all companies can succeed in selling their products, and then they have to try to reduce the project lead time in order to kind of be competitive. So lead time will have two definitions. So the first definition of lead time is our fundamental definition. So that is the time between a customer ordering the product and the time the product arrived to the customer's house. So the time between these two processes we call it lead time. And inside the company, we also have lead time as well. So this lead time is the time before or between we start to produce our products. The time between we initiate a product from its concept stage and design stage to the day we launch our product in the market after we produce this product and marketed its product. So that is a lead time within the company. So we have internal lead time and external lead time. We have to keep in mind of those. And now, in this lecture, we are introducing a new product innovation, so we have to know the concept of concurrent engineering. Concurrent, in other words, means working simultaneously. So this basically means work done together, but not separated. So they are not decoupled, but the work are actually done kind of together, kind of in a simultaneous way. So concurrent engineering is a key feature in our new product innovation, which you will see later. And then we have a flexible new product development process, which we call NPD. So starting from the next slide, when we compare NPD and compare NPD with the traditional, what we call sequential approach, you have to keep in mind we address the innovative approach as NPD. And NPD basically works in the CFT way, which we call which we address as cross-functional team. It's cross-functional because you remember we are doing concurrent engineering. So teams are basically working together to achieve the product, to achieve the goals. So that's why we're adopting this cross-functional team strategy in our NPD approach. Okay. So now let's compare our two approaches. So first of all, the graph you see now is a sequential approach. This is a traditional approach which has been implemented in companies long time ago, and you can see that each stage is actually separated from each other. So first of all, in our sequential approach, we start with our concept. So the business have to come up with the concept first prior to designing this product. After the concept is finished, then the design team will take place, will look at the concept and start to conduct design ideas. After design ideas are finished, they hand it to prototype, and the prototype team will start to make samples of this product, maybe through a bit of manufacturing, but it's really small size manufacturing, maybe a few samples only. And then after prototype has been decided, the product will be handed to the manufacturer stage, and the manufacturers will manufacture the product in larger scales. They're ready to be handed and to be launched in the market. After the products are manufactured, the marketing team will start to market the products through different ways, maybe promotions, advertisements. They have to decide on the packaging. They start to monitor the prices. They started to implement strategies. They may have to conduct a few market researches. So then they have to conduct marketing. After marketing is conducted, then the product will be launched to the market. In the services stage, when maybe you will be launched into retail shops, there will be inventories holding and be ready to be handed to the customer's house through e-commerce. So the delivery companies have to be ready, and then it may be launched to wholesalers. I don't know, but definitely that's a stage. A product is going to be launched to the market. So that is about the sequential approach. What are the characteristics of the sequential approach? So first of all, you can see the communication is actually a forward communication. What do I mean by forward communication? Because as you can see, there's no backward communication in the system. Because after the concept team has given the concept to the design team, in this case, the concept team is not working anymore because the design team have to come out with designs that are ready for the prototype. So the concept team cannot actually amend or cannot actually edit its concept. And once the design team has finished the designs and handing the design to the prototype on workers and employees, the design team have no turn back. They don't have any opportunities to change the designs, to remake the prototype. And when the prototype team finish its samples making and hand it to the manufacturers, prototype team doesn't have any work to do as well. So there's no backward communication, it's only forward or upward communication as the stages go ahead. So is this an advantage or disadvantage? I would say it's mostly disadvantage because certain benefit of this upward communication is time saving and coordination skills, less requirement of coordination skill, because if concept team have to receive certain backward communication, the company may be a bit chaotic, and it may more coordination costs can incur when a new concept is come out, and when the prototype team goes back to the design team, more costs will incur if the design team has to come out with more design, and especially in the manufacturing stage, if the product is not successful, and if the prototype team has to make a product again, goes back to the design, goes back to the concept, it is definitely more costly as well. So I would say forward communication has certain benefits, but yes, more harms, because the harm is, I mentioned before, is really costly. The benefit is time saving. I would say I guess you can agree with this, and less chaotic within the company, but definitely there's less turn back when the company follow this upward communication way, and there may be no turn back. So it's kind of you have to keep in mind this drawback in this sequential transition approach. Now let's look at the project lead time. As you can see in the x-axis, we have a project lead time, which I've explained before. It's the time difference between coming out with a concept and to the stage that we are launching our product into the market. So that is our project lead time. In the y-axis, we are seeing the project progress, which is basically stage by stage, and at 100% our product is basically finished and ready to be launched to the market after some marketing attempts and marketing efforts. So now I'm going to introduce to you the flexible NPD approach, new product development approach, along with a cross-functioning team. So in this approach, you can see the lead time is much lower, but that doesn't mean in all cases NPD will take a shorter lead time, because keep in mind NPD approach, as you can see, is an approach that's layered up. So it's what we call as concurrent engineering. So each layer is basically working together at any state of time. So it may have a shorter lead time because every stage are working together, but it may also have longer lead time if the company have to come out with new designs, because NPD is definitely more flexible. When there's a higher flexibility, it may take more time because maybe this product is not successful, and then they have to work on a second product starting from the concept. So now look at NPD approach. What you can see is when the team is working on the concept, the design team is already incorporated into this process. So the design team is coming up with some design ideas, and when they're still making the design ideas, the prototype team is coming into the game. And the prototype team is going to make samples based on the design given in the design team. And while the prototype team is coming up with sample 1, 2, 3, 4, 5, a manufacturing team is coming in to try to manufacture the product, and they try to market this product and launch this product in the market. But this whole process is still going on, which means they have a kind of a higher range of different products, and each team is working together in this state. But in manufacturing, it doesn't mean that it's going to manufacture a mass amount of products, because since NPD is like a combined process, there are many ideas that are going to be tried out in the NPD process. So maybe manufacturers will manufacture smaller scale products, a smaller number, and to try to market it in the market by the marketing department to see if it works or if the product is popular and is able to gain revenues and profit. So as you can see, both of these approaches have a lot of differences. So the sequential approach is most likely a stage-by-stage approach, but the NPD approach is more like a concurrent engineering approach where work is conducted simultaneously. So as you can see, in NPD approach, there's backward communication, which we call the feedback communication, because when the concept team gives this concept to design, if the design team find out there can be possible improvements based on this concept, they can actually talk back to the concept team, give some feedback, and the concept team is going to come out with the second concept. And same for the manufacturing or prototype stage. If the product doesn't work, if the products cannot be manufactured based on the design, then the design team or concept team will come up with a new product. Maybe the measurements are more accurate, maybe it's more possible with existing materials, existing raw materials. Then they will hand a new design to the manufacturers to see if the new design will work in the manufacturing stage, and they will give to the marketing team to see if consumers will be like to buy this product. If yes, the product is popular in 2021, then the manufacturing team will manufacture more products. But if they find out this product is not popular in the market, it's not able to get any profits or revenues for the businesses, maybe the design team will come out with a new product. Although the cost can be high, but then the lead time is actually low, and actually they save a lot of cost from external costs. Because if the product is not successful in the market after it's launched, after marketing is tried out, then the design team, but keep in mind, while the marketing team is marketing the first product, the design team is still coming up with new designs every day. So if the product is not successful in the market, the design team can quickly hand the new design to the manufacturer, so they have a second choice, they have more turn back. So both of them have respective advantages and disadvantages. And now let's look at my document here. So I made some annotations here for you guys. So now, what is risk exposure period? This is really important. So the risk exposure period is basically the potential risk that one can incur in the for the product. So basically, you can see in a sequential approach, there's much higher risk exposure period. The risk exposure period actually initiates once the product has gone to the design stage, because once the product goes to the design, there's no turn back. The design handed to the prototype, there's no chance to turn back and remake this product. But on the other hand, in the flexible NPD approach, there's a turn back chance, because the risk exposure period only happens to exist in the service stage where the product is launched in the market. Because if the product, when the product is still marketed, when the product is at its marketing stage, there's still turn back because the design team is still making the product. So the risk exposure period is much less. And you can see my writing here. The sequential approach can incur, can lead to a problem that we call the concept freeze or engineering freeze. This is a problem when the product is handed to the manufacturing stage, when the concept team, design team, and prototype team all finish their work, and the manufacturers now found this problem here. The product is not able to be manufactured. So then, the product is not able to be manufactured. So now there's a freeze, because now the concept team, design team, and prototype team are not working on the product anymore. So the manufacturer have nothing to do. So they kind of stop the manufacturing. So this is really scary. This can be really costly, because then they may have to start the product from the beginning again, from the concept stage. So all the time they spend from concept to manufacturing in this case are wasted, and they might have wasted a lot of cost in between as well. But if we look at NPD approach, if the product doesn't work in the manufacturing stage, it is still possible to quickly implement the manufacturing process of another product, because we know the design team is still working in the same time as we draw a straight line here. They are doing concurrent simultaneous work right now. So that's about engineering freeze and concept freeze that can occur in a sequential approach. Now let's look at some advantages and disadvantages of both of these approach. So first of all, the characteristic of the sequential approach is basically one-to-one, one-directional upstream communication. So I've talked before, it can be beneficial or not. It is actually more risky especially when customers' preferences change in the market. There's no turn back. There can be more external cost, which is a cost when your product is not popular, it's not making any sales once it's implemented in the market, because then you already spend a lot of cost in research and development in this whole process from concept to manufacturing to prototype to manufacturing to marketing and services. So it can be costly, but it can also save a lot of time. It can increase efficiency. So that is basically the nature. We call it one-directional communication, one-directional process in our sequential approach. On the other hand, in our flexible CFT approach, we have multiple functions working simultaneously. So there's a constant feedback and upward and downward, I would say upstream and downstream communications are both present in our flexible approach. So now by looking at this graph, I've actually listed more disadvantages for CFT, but that doesn't mean CFT is not as good as traditional approach. It is because traditional approach have a main disadvantage, that is problem solving capability and risk exposure. In the list here, it's just a few words, but actually they have a more cost than this kind of a smaller than this kind of a list I listed in the flexible approach, because when there's higher risk exposure, it can be really dangerous depending on the situation. So now what are the pros of the traditional approach? So first of all, it's quite simple. There's a simplicity involved, and there's a simple accountability. Most of the CFT's disadvantages are solved. Kind of don't occur much in a traditional approach. And the advantages of CFT, basically, first of all, is the lead time reduction. However, I want to clear it up that lead time may be even longer, because I mentioned before, if product 1 doesn't work, maybe product 2 will be tried out, and then product 3. So maybe eventually it may take a lot of time. But the result is it may be less risky. So even if it takes a longer time, it takes a longer lead time, but then it means the product may meet the customer taste after a long time of trial and error. So even you may have so lead time can be an advantage, but sometimes it may not be shown out really clearly. But in the end, if there's a higher lead time, usually it means the business is actually now creating a product that will meet the customer's preferences in the market. And we increase our problem solving capability. While increasing our problem solving capability, because we're able to make changes to our product from the concept stage, because we're doing concurrent engineering, and we're incorporating changing customers' requirements inside our approach, because once there's any change of customer requirement, we can make changes. And we're incorporating cutting-edge technological innovation. We have innovation involved because there's a feedback stage. So even if customer requirement is not changed, but every stage our team members in all stages can provide advices to other teams below, to our downstream, giving our downstream communication, give some downstream feedback. So in the end, maybe we can innovate our product better because we're coming up with more designs, more concepts, we're brainstorming more ideas, we're implementing more ideas into practice in our CFT engineering. But what are the disadvantages from this? It's basically, we know its coordination cost is increasing. But why is coordination cost increasing is really easy, because when we are working concurrent engineering, when we're simultaneously working on many processes, we're putting more costs to coordinate the department, because in the first stage, when the concept team finishes work, it's over for him. Maybe he'll take on other tasks, but his task for this project is done for now. But in the CFT approach, all the teams have to work together simultaneously until this product is published in the market, until the final product is published in the market. So definitely there's higher coordination cost between from the manager to definitely also there's more waste can be incurred, duplication, because more products are going to be trialed. You can say it's more like a trial and error, because if a product doesn't work, they're trying a different one. But then definitely there's higher waste incurred, both material waste and basically in the end it's basically waste of money. And then we have maybe chaos can result in our company. This can be a severe issue, happens in our CFT approach, because there can be confusion. It can be concurrent chaos. If there's chaos go to a certain point, efficiency can decrease, and it can be even worse. It can be much more worse than the sequential approach, because even the product cannot even come out in the market. So it can definitely be really costly if there's a chaos in the company. So definitely the company have to be working well. So, and also you should learn from its mistakes. So a new company who's applying CFT may not be successful because it's really hard to get department working closely together with efficiency and with accuracy well in a smooth way for a new company in the market. But after you try for a long time with this approach, I certainly believe that your company will be able to manage CFT approach very well after a few attempts, because I mentioned in our lecture 0, learn from our mistakes. The bitter way is the bitterest way, but it is the most effective way, as what Confucius said. Confucius said. Okay. Employee morale, employee exhaustion can decrease. Many people argue this point because, sometimes while we just imagine this work, we feel like CFT is kind of a really good way to process our products, really innovative way. But when we look closely, when we actually we are not just thinking in our house, but we're actually implementing this practice in real life, which many university students have done so during their work, maybe summer work, and they found out that employees' morale will decrease a lot in these processes. It may not be a problem in companies like Microsoft and Apple because they have a higher success rate and they have a well system. Their employees are elites. But sometimes employees are not going to work as what you wanted to be achieved in your company. So exhaustion can be a problem when they're coordinating, and after the chaos, they might not be able to know what they're doing. And their moral is basically their enthusiasm and their activism, their commissions, they're committed to do their activism, their kind of hard work put into the product, put into this process will decrease a lot, and it can decrease drastically. So these are the advantages and disadvantages of CFT and sequential. Look at the disadvantages of the traditional approach. Basically, is lead time will increase, there's higher risk exposure, and the problem solver capability goes down. This can be really severe. This is why many companies now are adopting the CFT approach. This is because risk exposure increases, it can be really costly. I mentioned before, if the customer's privacy change, if the product is published to the market but it's not gaining any popularity, it's not making any revenues, it's kind of really costly. That is external cost. So now I hope you guys have a better idea with our CFT and traditional approach. And in the next lecture, in the next part of lecture 5, we're going to go deeper in our CFT approach. We'll look at some graphs, and we'll then we are going to go through the stages of change. How can we make change to implement new product innovation in our company? So look up and stay tuned for our second part in our lecture 5 on new product innovation, and I'll see you in the next video. Thank you.